Hello sailors, welcome back to Sailor Ravi, and in this video we'll try to solve a Naval phase 1 for the chief mate questions. So here we have the first question which says we are loading a grain in bulk which is stowage factor is 1.2 meter cube per ton, which has a weight of 88,000 and kg is around 10.3, right? And FSM is 2650 metric ton, km is 13, and filled compartment volumetric healing moment is 5800 meter power 4, and this partly filled whole compartment is 14500, and angle of flooding is 38 degree, and here we have the kn values. So this question is asked in, as you can see, this question is asked in 2022 May. So we'll try to solve this question. So if you're really interested in such kind of video, please hit the subscribe button. Subscribe the channel which is Sailor Ravi. Sailor Ravi. Right. So let's start the question. As we see, the questions has SF is given. SF is 1.2 meter cube per ton, and this 88033 ton. KSA is 10.3 kg, and FSM is 2650 metric tons. So FSC equal to 2650 upon 88000, which will be around 2650 bhaga 88000 will be around 0.030. This will be the FSM. So now we'll have like kg. So corrected kg will be 10.3 plus 0.033. So corrected kg is 10.33, right? Given as km is given 13.0, so gm will be 13 minus 10.33 will be gm will be 2.67 meter cube, right? So this is the first part of the question. Now we'll be going for this table, right? So as we can see that heel is given and kn is given. We need to find out the gz. We need to find out the gz curve, and we have to satisfy the grain requirement of the bulk, right? So very first thing we'll do, like in the question 12 degrees given, 15 degrees given, 30 degrees given, 40 degree and 45 degree, right? And kn is 2.75, 3.45, 3.45, 6.86. Oh, I think I'm making some mistakes here. Mistakes is here. For the 30 degree it's 6.86 and 8.59, and this will be 9.30. So now we have to calculate, as you can see, this is given in the question, given in the question, right? Now we have to find out sine, right? So if you put the sine, so sine 12 degree will be okay, we'll complete this sine, and then kg which is the corrected kg, right? Then kg sine theta will be written, and then will minus kn minus kg sine theta, which gives equal to zz. You can say this is the gz curve, right? So we'll start from there. So sine 12 degree will be like 0.20 you can take it, and kg is around kg is 10.33, so 10.33, 10.33, 10.33 and 10.33. so we'll bring it together into 10.33. so this will be 2.147. We'll take 8. So such kind will go sine 15 degree is 0.258. So such 0.258. So into 10.33. So it will be 2.673. Okay. So by doing such calculation, we'll have like in the kg section, we'll have 5.165, 6.640 and 7.340. And when we'll reduce this section will be reduced by this section, right? So when we'll be reducing this, it will be 0.602, 0.777, 1.695, 1.950, and this will be 1996, right? So this is the initial we have to do. Then we'll try to plot the based on this we'll try to plot the graph. So we'll take 1 centimeter equal to 1.2, right? So we'll be just doing like this and just marking where is matching. So this will be 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this will be enough for our calculation, and this will be like 0, right? So when it will be 0, so now we'll be plotting like this, and it will be like 10, somewhere 10, right? So this will be 10, 20, no, 5, 10, 15, 20, 25, 30, 35, 40, 45. So we have like 45 only. So now let's just do this. 0.2, 0.4. Am I visible? Yeah. So 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, right? Now here 5 degree. This is GZ, value of GZ, right? So you can just write, you can use the graph paper as well, right? This is just a practice, so I'm not using the graph paper. And this is heel. So 5, 10, 15, 20, 25, 30, 35, 40 and 45. These are the heel, right? Now we'll be trying, as you can see on the 12th, degree of heel, we have like 0.6. So we'll plot somewhere like 0.6. Let's say this is 12 and 0.6 will be here. 0.77 on 15 degrees. So this is 15 degree, and 0.77 will be somewhere, this is 0.6, and the 15 will be somewhere. Where is the 15? Here is the 15, and 0.77 will be here. Now 1.7 30 degree pace, 1.7, so will be going here, and 117 will be here only, right? In the between of this, yeah, you can put the 1.7 here, right? Now 1.2.0 on the 40 degrees 2.0, so we'll be putting like here, and 45 is 1.19, so will be somewhere 45 will be like this. So these are the graph. So just connecting the all dots. So these, as you can see, these are the rough connecting. So this is the graph, and as you can see, there will be the angle of flooding at 38 degrees. So this will be the 38 degree will the angle of flooding. These are the total area under the GZ curve. So we need to find out the, is he satisfying the this criteria of this grain code. So as now we'll have to calculate the volumetric healing moment, right? So for VHM now, okay, so we'll remove the phone. So here we have, now we'll calculate the VHM in the question where it goes, yeah, filled hold VHM equal to 5800 metric tons. So we have factor is 1.2, right? Factor will be 1.12, and so by multiplying VHM of this will get around no, for the compartment we don't need work. I'm really sorry, for the filled compartment we don't need any factor. For partly filled hold के लिए VHM is given 14500 meter 4, and the factor is 1.12. so total VHM total partly filled VHM will be 6240 meter cube. So now total VHM equal to 5800 plus 16240 equal to 22040 meter cube, right? And this is the thing. The next page you can do is, right? So now we have this. So we need to lambda 0 equal to total VHM by SF into this. So total we have, right, 22040 upon SF is 1.2 in the question, and total displacement is this. So lambda 0 will be 0209. Lambda 0. Lambda 40 is 1.8, 0.8 into 2.09, right? So it will be somewhere 0.16. So now we'll be like drawing something. In the graph we have to plot the lambda 0 and lambda 40. As you can see, lambda this will be like this. So this is lambda 40, and this is the lambda sorry, this is the lambda 40 and this is lambda 0, right? So now we have to find the for this grain, to satisfy the grain code we need to find this area. We need to find this area, right? Okay, so we need to first find this. We need to find first we will find the whole area, then we'll have to minus this triangle and this trapezium, right? Then we'll get this. So for the next phase of the question, we'll try to calculate the whole area. So as per Simpson's rules, we'll try to do stations, ordinates, and ordinates, and then SM, and then product POA, right? So station will be 0 degree, 9.5 degree, then 19 degree, then 28.5 degree and 38 degree because of angle of heel, right? Ordinates will be like 0, 1.45 as per the graph we can take. So I have already completed this question and just repeating for you guys. So 14241, right? So it will be 0 here, and 1.8 will be here, 2.20 will be here, 6.60 will be here, and 1.90 will be here. So total SOA equal to 12.50. So as per applying SM rule first, H by 3 into SOA, H equal to, as you can see, H equal to 9.5 by 3 into 12.5 upon 1. To change this radian into meter, so this will be meter, so this will be 0.69 meter radian, right? So this is the entire area. Entire area is meter radian. So this is the entire area of that, but we have to calculate, we have to see is it satisfied the grain code. So we'll have to check the dynamic stability of the ship, right? So next part of the question is like this. We need to calculate the area of the triangle. Which area? So this area of the triangle we have to calculate. So triangle area equal to 1 by 2 into base will be 0.25 into 4 into to change this degree into meter radian, so we need to always divide by 57 point this. So 0.25 will be the height of this, because lambda 0 is like this. Where is the lambda 0? Lambda 0 is this, so 0.25 will be like this, and 4 will be the base, because see, it is coming on the 4 degree. So 4 degree, to change the degree into meter radian we have to divide by 57.3. so it is 4 degree from here, angle of heel. So it will be calculated as 0.0087 meter radian. So these are the angle of trapezium area. In this we need to calculate same procedure, 1 by 2 into plus करते हैं, and plus will be 0.25 plus 0.18 into 38 degree minus 4, because angle of flooding and angle of heel के बीच का distance हमें चाहिए, that's why, and then divided by 57.3. so it will be around 0.127 meter radian. So now we have to check the total area. we'll check now. Residual area, right? So residual area or total area minus these areas, right, into plus. So total area we get is 0.69 minus 0.0087 plus 0.127, so it'll be around 0.5543 meter radian. So this is the completion of the question, but we have to as you can see in the question, whether C satisfied the stability criteria. So now we have to we need to check. So as in the grain, bulk in grains, so first is GM should be always more than 0.3, right, 0.30 meters. So now as we can see, GM is in the previous GM will have, where the fucking GM, yeah, GM. So GM is this. So GM is satisfying because GM is somewhere 2.67 meters, so it is satisfy the rule 1. दूसरा है कि the area under the GZ curve should not be more than 0.075. so area under the GZ curve, so GZ कर्व का एरिया जो है वो should not be less than, I guess, should not be less than 0.0075, right, meter radian. So in this we get this 0.5543. it is also satisfying the rule. Third is angle of heel should not be more than 12 degree, not more than 12 degree, and we have angle of heel equal to 4 degree, and vessel is upright. So these are the conditions. So this is the completion of the question. If you like this explanation, if you like this questions, you can take the screenshot, and please hit the subscribe button for future updates of the MMD question of the chief mate phase 1. So these are the questions, and you need to practice a lot. We have to finish this question in less than 20 minutes, and as per the video we get only we finished in the 20 minute. So we'll try to practice as much as you can. So these are the questions. Thanks for watching the video. Please hit the subscribe button, and you can ask me any M&A question in the comment box. Thank you.